Hey, welcome back. Today we're going to talk about something you think you know inside and out, blood sugar. But it turns out, the story we've all been told, well, it's missing the most important character.
So let me just ask you something. When I say blood sugar regulation, what's the first thing that pops into your head? I'm willing to bet for almost all of us, it's the pancreas, right? And of course, insulin.
You know the drill. We all learned this in biology class. You eat something, your blood sugar goes up, your pancreas sends out insulin, and that insulin tells your cells to soak up the sugar. Everything goes back to normal. Simple, clean, makes total sense.
But what if I told you that that simple little story is like trying to describe a whole orchestra by only talking about the violin section? Yeah, it's a critical part for sure, but it completely ignores the conductor who's actually running the entire show.
Okay, so let's get into the good stuff. The real commander-in-chief of your entire metabolism isn't hiding out in your abdomen. No, it's that 3-pound universe sitting right between your ears, your brain. It is the body's central processing unit.
See, the body's real job isn't just handling a little sugar after lunch. It's a huge, constant logistical puzzle, balancing the energy you take in, the energy you use, and the energy you store for later. That kind of complex coordination, it needs a central command. It's way too big of a job for just one hormone.
And right here, this is where it gets really cool. Because you have to ask, wait a second, the brain is basically in lockdown, protected by this super secure thing called the blood-brain barrier. So how on earth does it get the real-time intel it needs from the rest of the body to manage this whole energy budget?
Well, the answer comes down to a group of unsung biological heroes that you have probably never ever heard of. They're called taniocytes, and you can think of them as the brain's secret service agents.
So what in the world is a taniocyte? Imagine a super sophisticated bouncer at the most exclusive club in the world. This cell literally has one foot, so to speak, in the bloodstream, and the other foot wired directly into the brain's neural networks. It is a living bridge, constantly sampling what's going on and deciding what information gets passed up to the boss.
And this job is absolutely critical. Without these taniocytes, the brain would be like an open inn, just vulnerable to every chemical rumor floating around in your blood. But instead, these cells turn it into a guarded government building. Only the most important, pre-screened information, like exactly how much glucose is in your blood right now, is allowed to get through.
Okay, so we've got this hard biological data coming in, but how does that, turn into something we all experience every single day? How does it become the feeling of being hungry or the feeling of being totally stuffed?
It's basically a direct phone line. The taniocytes sense the glucose right there in the blood vessels they're touching. They then translate that chemical fact into an electrical signal and fire it off to a very specific command center in the brain called the arcuate nucleus.
Now, this arcuate nucleus has two groups of neurons that are basically on opposing teams. When the taniocytes report that glucose is high, they flip on the POMC neurons. That's your I'm full signal. But when glucose is low, they activate the other team, the NPY neurons. And that's your I'm hungry signal. It's this beautiful, elegant on-off switch for your appetite.
And this whole thing isn't just about boring mechanics. It's wired deep into our survival instincts. This system is designed to create a powerful, primal motivation. Just think about a leopard risking its life on a hunt. The brain is what creates that intense drive for food, and then it delivers the incredible pleasure of eating as the final reward. It's a system perfected over millions of years of evolution.
So this all leads us to the big question, right? Why does any of this matter for us right here, right now? Well, because it could completely change how we approach some of the biggest health crises we're facing today.
This is a whole new frontier. I mean, think about it. Instead of focusing almost exclusively on the pancreas and insulin, we can now look at the actual commander, the brain. This could lead to entirely new ways to treat obesity, type 2 diabetes, you name it, because we'd be targeting the control system itself, not just cleaning up the mess downstream.
So, let's end with this thought. For decades, maybe centuries, we've been trying to manage our metabolism by dealing with the players on the field. But now we finally know who the commander is. And that leaves us with the ultimate question. Now that we know who's in charge, can we finally change the rules of the game?